Hi everyone, I'm Mr. C and welcome to the Detroit Children's Museum for another video. Behind the camera we have Mr. Don. Thank you, Mr. Don, for assisting as always. Today, everybody, we're going to become naval architects and marine engineers. And while doing the activity, you will discover what those two possible careers entail. What kind of skills do you have to have? Do you need to know mathematics? Yes. Do you need to have understanding of space, geometry, that type of math? Yes. Do you have to have understanding of science and designing? Yes. We're going to answer the question together. How can failure lead to success? One would argue that you cannot have true success without failure. And we have a negative connotation to that word failure. You'll have success, I guarantee it. So marine engineers, naval architects, let's go. You have materials you need. A sheet of aluminum foil, 2 sheets. What I did was I spread a sheet of aluminum foil in front of me. I traced this book and simply cut it out, folded it in half so that I have now 2 equal size or sheets, okay? We need some masses, some load. We're going to use pennies. You could also use what? I hear Legos. Sure. I like the way you use Legos because they can stack. You can connect them. Might make it easier to do what we're going to do in a minute. What else could you use? Duplo blocks? Sure. Sure. Try different things. All right, for the first boat, we're going to design boats. You're a marine engineer, along with other types of engineering. That's what we're going to be first. And we're architects. You may want to draw a design first. And you're going to construct a boat. All right, something that floats in this tub of water before me. And you want to hold the pennies or whatever load you decide to use. So I'm going to make a small little design here. And you can take your time with this, of course. There's no hurry. I'm going to pinch the corners. Aha. Something like this. Okay. And then you place it carefully into the water. Hopefully it'll float. And it does. So then you test it. But first, make a prediction. Design engineers, scientists, mathematicians employ the scientific method. Okay? How many pennies do you think this boat will support? I have 10. All right. And maybe you're not sure. Is it okay to be unsure? Absolutely. But place a number on your paper, okay? And it's good to do this together. It makes it more fun. It may even make a contest or a game out of it. Okay? So far we have 2. You already started counting with me, didn't you? You've watched our videos before. 3. 4. I'm carefully placing them around the boat. I now have 5. 6. 7. 8. 9. 10. And you certainly don't have to add the load to the boat the way I am doing. What's that? 11. 12. 13. My goodness, we're going to be here all day, right? No, it'll be 14. 15. 16. 17. 18. 19. 20. Whoop. Nope, I missed that one. 20. 20 sunk my boat, so we're going to call it 19 pennies. Now, if you want, you could use the same piece of foil. But my students would say, no, I want a clean one. So, very simply, inexpensively, we can just have the 2 sheets, 2 sections, 2 pieces of foil the same size. How can failure lead to success? 20 pennies created failure for my boat because it would not hold 20, right? So my boat failed. Now what you have to say or ask yourself, ask each other, can you design a new boat that holds more? So let's do that. I think I'm going to go total different design. As a design engineer, as a marine engineer, designing is involved in that. There's other types of engineering, structural design engineers, so many different types of engineering. Consider engineering as a career for you. There's my design, okay? Now we had my previous design held 19. 20 created failure. Can I beat 19? Will this design hold more than 19? At least tie it, I hope, right? We'll see. I predict this will hold 25 pennies. Minimally. That's 1, 2, 3. And remember, patience. Be careful. 4. Carefully adding the masses, the pennies. 5. 6 to your newly designed boat. 7. 8. 9. Tim, what great counting practice, right? 11. 12. 13. 14. 15. 16. 17. 18. 19. Now, this design has tied at least the design there. Do you think it's going to hold more than 19? Let me just give this a little spin. Is there any sign of impeding failure? I don't think so. What do you think? 20, 21, 22, 23, 24, 25. It at least held 25. We can go on. 26. My students used to try this. 150, 160, 27, 28. 28 created failure. So my design, this second design, my second boat with a different design than my first, held 27, supported 27 pennies. That's excellent. So how can failure lead to success? I looked at design that held 19, said, wow, if this held 19, and I'm thinking, okay, like a boat is like a bowl shape, kinda, right? That's what I was thinking. What were you thinking? What kind of design can you create? And again, sketch these. Write down your data. Did you know there are 6 major branches of engineering? There's mechanical, chemical, civil, electrical, management, and geotechnical. Marine engineering, where would that fall? What do you think? Okay? And to wrap this up or to tie this together, have them write a comic strip. And in the comic strip, they're drawing pictures and adding words, descriptions of what were the step-by-step instructions to do to complete this activity and what they discovered in a comic strip. Why not, right? I'm Mr. C. Thank you for joining us today. Behind the camera, once again, is Mr. Don. We appreciate your support. Take care.